In this video, we are going to consider how to add and subtract surds. So let's just start with a bit of context. Let's say we have something like 8 root 3 plus 7 root 3 plus 3 root 2. Now, how would we add these together? Now, a couple of key things. First of all, it's worth mentioning at the outset that we treat surds as if we were adding terms with algebra. So if we had something like 3x plus 2y, we know we would only add the x's together. So we'd get 6x plus 2y. We don't add the y's to the 6x to get 8xy. Exactly the same thing goes for surds. We can only add like surds, so that is surds with the same term underneath that root symbol, and we leave any of the other leftover surds outside. So when we're simplifying surds, like with algebra, where we just add the coefficients together to get 6, we're going to be adding 8 and 7 together, okay? So let's do this question. We have two surds which have the root 3. So those are our like surds. This one is not a like surd because it has a root 2, so there's not much we can do with that. In terms of the like surds, we have 8 root 3 plus 7 root 3. That simplifies down to 15 root 3 because 8 plus 7 is 15, and then we're left with just 3 root 2. Okay, let's have a look at another example. Let's say we have 3 root 5 minus 4 root 5 plus 4 root 3 minus 3 root 5. So once again, identify all of your like surds and then add the coefficients, or subtract in this case. And if you need to do the simplification in more than one step, then feel free to do so. So let's start off with, we have 3 root 5 minus 4 root 5. Immediately that's going to be minus 1 root 5, or we can just write that as minus root 5 as we wish. And then I'll just write the rest out here. Then let's keep going. We can't add this one because that's not a like surd, but we can subtract 3 root 5. So when we'll do that, we'll have minus 1 root 5 minus 3 root 5 is going to give us minus 4 root 5, and that's going to be added to 4 root 3. And that's our final answer. Let's do another final example. Let's say I have something like root 27 plus 3 root 3 minus 4 root 5. Now, I've chosen this example deliberately because you might say, well, there's no like surds, we can't possibly add any together. But you'd be mistaken, because with this root 27, this can actually be broken down, and we can see potentially if it'll end up with a root 3. Let's see what that looks like. In terms of root 27, remember to simplify surds, we need to think of two numbers that multiply to give 27, or whatever our term is underneath that surd symbol. And one of those numbers that we think of needs to be a square number. In this case, we know that 9 multiplied by 3 is going to give us 27. So we can rewrite root 27 as root 9 times 3. Then what we can do is separate them out. So we have root 9 times root 3, and then simplify. We know root 9 is equal to 3, so then our final answer is going to be 3 root 3. And see, there you go. This also has a root 3, just like our 3 root 3 here. So let's move on from here. Instead of root 27, we're going to write 3 root 3 plus just the rest, 3 root 3 minus 4 root 5. Then simplify down, add our coefficients. So we have 6 root 3, and then we're left with minus 4 root 5. Excellent. So that concludes our video on how to add and subtract surds. Remember, it's quite like algebra. In the same fashion that we wouldn't add unlike terms, we cannot add unlike surds. However, be very mindful of situations like this, where sometimes it might not look like we have a like surd at first glance, but if we simplify a surd down, as it turns out, we did have a like surd after all. So just be careful about that.